Okay. So we can start. We can start. So we are going to start from the first section, which is section 1.1, which is the systems of linear equations. Systems of linear equations. So again, this class is, the topics are very many. So we'll try to go very fast, a little bit fast. Try to go a little bit fast. So the first section is number 1, which is system of linear equations and their solutions. 1.1. Let's start from the definition. The definition. So a system of linear equation, or linear system, is, in n variables, let's say x1, x2, all the way to xn, is a collection of finitely many equations of the form a11 x1 plus a12 x2 plus a1n xn, which is equals to b1, a1 or a21 x1 plus a22 x2 plus a2n xn equals to b2. So it can continue like that up to the point a m1 x1 plus a m2 x2 plus a mn xn equals to bm. So a system of linear equations or linear systems in n variables, say x1, x2 to xn. So all these x1, x2, xn are the n variables. So it forms a system of that form, a11 x1, a12 x2, all the way up to b1, and then all that. So where aij, where I equals to 1 all the way to m, and j equals to 1 to m, to n, are given numbers. So a11, a12, a1n, so those are the coefficients which you are given. So actually, you also make sure that you also consider the sign. So like, let's say if there was a negative here, then the coefficient of x2 here is negative a12. So we'll see on some of the examples there. So aij, this I are from 1 to m, and then the j are from 1 to n, are the coefficients are the coefficients, and the bj, where, or let's say bi, where I is equals to 1 all the way to m, where I is equals to 1 all the way to m, are given numbers called the constant terms. So those are the constant terms, the constant terms. Now, the solution of this linear system, you can say the solution of the above linear system, the solution of the above linear system is a list, of numbers S1, S2, all the way to Sn, such that all equations in the linear system holds when x1 equals to s1, x2 equals to s2, xn equals to sn, xn equals to sn. Now, in this linear system here, you can solve this linear system, and the solutions are what you get for x1, which is s1, x2, which is s2, xn, which is sn. So you can actually solve that. So we'll see many ways of solving this linear system. So one of them is by matrices, Okay. So let's look at example number one. Example number one. Example number one. Show that x1 equals to 2, x2 equals to -1, x3 equals to 1 is a solution of the following linear system. So we have x2 plus x3 equals to 0, x1 minus 3x2 equals to 5, and then minus x1 plus x2 plus 5x3 equals to 2. So we want to show that
On the first line, x2 equals negative, is that -1?
yes, x2 is equals to -1. Show that x1 equals to 2, x2 equals to -1, x3 equals to 1 is a solution of the following linear system. Okay, so how do we show this? So let's prove this. So we know that x1 equals to 2, x2 equals to -1, x3 equals to 1. So let's now see this. So when x1 equals to 2, x2 equals to -1, x3 equals to 1, then x2 plus x3 equals to 0 is equals to, so we know that x1 is not there in the first equation, right? So that means x2 here will be 2 plus x3 is I'm sorry, let's change this. Let's say x1 is 1. x1 is 1. x1 is 1. So we have 1 and then plus, negative 1 plus x3 is what? x1 equals to, and this one is equals to what? Equals to 0. When we come to the second one, x1 is, I don't know what I'm doing here. I don't know why I changed. This is 2. That is 2, x2 is like that. X1 here is x1 minus 3, x2 equals to 5. So let's see if that is a solution. If that is a solution. So we have x1 is 2 minus 3 x2. X2 is what? Negative 1. And this one is giving what? So it is giving us 2 plus 3 equals to 5. So that is a solution. That is also the solution. So x minus x1 plus x2 plus 5x3 equals to 2. So let's see this. So this is equals to negative x1 is 2 plus x2 is negative 1, and then plus 5. x3 is what? x3 is 1. And this is giving us minus 2 minus 1 plus 5, which is equals to what? Which is equals to 2. Which is equals to 2. So this shows that x1, x2, x3 is the solution of that linear system. So we can say that all equations in the linear system hold when x1 equals to 2, x2 equals to negative 1, and x3 equals to 1. x3 equals to 1. So we can say that, so x1 equals to 2, x2 equals to negative 1, x3 equals to 1 is the solution of the linear system. Is the solution of the linear system. Any questions? Any questions? Okay, now let's come to the next section, section 1.2. 1.2, and this one is the equation. Equivalent. The linear system. Equivalent linear system. So what is this equivalent linear system? Okay, two linear systems are said to be equivalent if these two linear systems have the same solution sets. Two linear systems are said to be equivalent if these two linear systems have the same solution sets. This means that that is every solution of the first linear system is the solution of the second linear system. So if the two linear systems have the same solution set, so we say the two linear systems are equivalent. They are equivalent. So for example, so let's look at example number 2. example 2. Let's look at example number 2. Find the solution. Find all the solutions of the following linear system and sketch the graph of the equation in a rectangular system. Find all the solutions of the following linear systems and sketch the graph of the equation. Two x1 plus 4x2 equals to 1. x1 minus 3x2 equals to 3. So let's find the solution of this linear system, and we need to sketch the graph. So if you did level 08, then there are many ways of doing this, getting the solution, which is of getting the values of x1, x2, x1, and x2. So one of the ways here is by use of elimination method. The other one, we can use the substitution method, right? Yeah, so here it is so easy to use the elimination method. So in this case, to use the elimination method, we can eliminate x1 here by multiplying equation number 2 by what? By 2. So here we get 2x1 plus 4x2 equals to 1. And then 2x1 minus 6x2 equals to what? Equals to 6. And then we do what? We subtract. So once we subtract this equation, then what do you get? This is 0. 4x2 minus 6x2 is what? 10x2. 1 minus 6 is equals to -5. And this will give us what? So x2 equals to -5 all over 10. And this is similar to 1 over 2. Now, we go back, we take this one back to this linear system up here. So we don't use the next equation here. So we can use the first one there. So we have the x2, which is -1 over 2. So we say 2x1 plus 4, x2 is -1 over 2, which is equals to 1. So 2x1 minus 2 equals to 1. So 2x1 equals to 1 plus 2, which is equals to 3. So x1 equals to 3 over 2. x1 is equals to 3 over 2. So that is, so x1 and x2 are the solutions of that system. So x1, which is equals to 3 over 2, and x2, which is equals to -1 over 2, are solutions of the system. Are the solutions of the system, of the linear system. Now, how can we sketch this? How can we sketch this one? So to sketch this one easily, then we can take the x1 to be the horizontal and the x2 to be the vertical. So to sketch this one, so we can take this one as x1, and then this one as x2. So we can say this is 1, this is 2, this is 3, this is 4, 5, 1, 2, 3, like that. -1, -2, -3, and then -1, -2, -3. Okay. Now, how can we sketch? How can we sketch? So we have this linear system, 2x1 plus 4x2 equals to 1. And then we also have x1 minus 3x2 equals to 3. So how can we sketch the first one? How can we sketch the first one? So what we can do is we can let x1 here be 0. Yeah. So when x1 is 0, so when x1 is 0, or we can say we can let x2 to be 0 so that it can be easier. So when x2 is 0 here, when x2 equals to 0, then x1 equals to what? Equals to 1 over 2. Now, when x2 is, yes, so now you come here, you say now x2 is 0, and then x1 is 1 over 2. So our coordinate here would be 1 over 2, and then 1, and then 0. So we have 1 over 2, which is here, and then we have 0, which is where? Which is there. Which is there. Now, when x1 is 0, when x1 is 0, then x2 is what? So when x1 is 0, when x1 is 0, then x2 is 1 over 4. When x1 is 0, then x2 is, let's say, 1 over 4. Let's say it's there, somewhere there. Now, we can sketch this one, so we can draw a straight line because this one is a linear system, so it can actually go on a straight line like that. A straight line like that. Now, when we come to the second one, when x1 minus 3x2 equals to 3, when x1 is 0, when x1 is 0, then x2 is equals to -1, right? -1. So we come here, so 0 and -1. So we have 0 and then -1 is somewhere there. Okay, when x2 is 0, when x2 equals to 0, then x1 is what? X1 is 3. X1 equals to 3. So we can take this one as 3 and what? And 0. So we have 3 and 0, which is here. And then you can do what? You can plot a straight line there. Straight line there. A straight line there. So this is for 2x1 plus 4x2 equals to 1. And this one is x1 minus 3x2 equals to 3. Equals to 3. Yeah.
Is x1 usually on the x-axis and x2 on the y-axis?
Yeah, it can also work. So you can actually interchange. It can work. So where they meet, where this line, where they meet, we have not drawn to scale. Where they meet here is the solution of that linear system. Is the solution. Where they meet here should be 3 over 2 and And the other one was what? Minus 1/2. 3/2 minus 1/2. Where they meet is the solution of that system. So you can, so these are the two ways of getting the solution of this system. One is by use of the elimination method, which is this. And then the other one is by sketching. So you can sketch it. So once you sketch it, you get the solution of that linear system, which is here. The solution is there. Any question? If there is no question, then let's now come to section number 2, which is now the matrices. And let's start from 2.1. 2.1. This one is the definition. The definition. A matrix is a two-way array of numbers placed inside a pair of square brackets. Yeah, of square brackets. If there are m rows and n columns in a matrix, then the matrix is called an m by n matrix. An m by n matrix is of the form. So we have A11, A12, A1m, A21, A22, A2n. It can go all the way to AM1, AM2, AMN. So here we have m rows. So we have the m rows, and then we have the n columns. M rows, and then n. So actually this A11, A12, A1n, A21, A22, A2n, those are the coefficients of the linear system, which we just had previously. So these are basically the coefficients of the linear system. Now we can use this one to get us solutions which are x1, x2, x. So in our case, if we have A11, A12, A1n, and then we also put it here x1, x2, xn, and then equals to b1, b2, last of them. So we can get the values of x1, x2, x3 up to the last of them by solving. We'll see some of the ways of getting that. So this is a matrix. So this one is an m by n matrix, an m by n. So in this case, where the given numbers aij, where I equals to 1 to all the way to m, and j equals 1 to all the way to n. So these are called entries. Moreover, the entries AIJ in the J row and in the ith row and J column of the matrix is called the IJ H is called the IJ. So I throw and then the J column. So we can call that one as well. IJ H. IJ H. Okay, now let's come to 2.2. 2.2. Coefficient matrix. What is the coefficient matrix? Coefficient matrix. So we can say the coefficient matrix our time is up. We can meet on Wednesday and then we can continue from there. So I will put the recording in Moodle, and then also the first homework will be there today. Okay. Okay, before you go, I think I need to check your class register here. Ash, Joseph, you can see your names here. Brenna, Greet, Nicholas, Morgan,
Here.
Austin, King,
Yes.
Freddie, Andres, Patrick, Austin,
Here.
Kent,
Here.
Rowan,
Here.
Sam,
Here.
Victoria.
Here.
Okay, see you guys.